All right, so problem 5, this commuting problem. The guy's going to go to work. He has route A and route B. He does 20 trials of each, and then he gets the statistics of each route. So we got to find a 95% confidence interval, and then he says that we got to figure out if, in part B, there's evidence that route A will save us 5 minutes. Okay, so here's what our statistics are. So that's the average time for route A, the standard deviation for route A, the number of trials for route A, and the same thing with route B. So we're going to do our parameter. U of A is the mean time of route A. Mu of B is the mean time of route B. Okay. The assumptions. These routes were chosen randomly by, the problem says, by flipping a coin. The times for each route are independent. 20 trials for each is less than 10% of all trials. Okay, so that's 1, 2, 3. And then the problem says that the histograms are roughly unimodal and symmetric. Okay. Okay, so the name of our statistics, okay, well, this is going to be a two-sample, this is a two-sample t-interval. Okay. The statistics are this, and then x bar of B is 43, standard deviation of B is 2, number of B is 20. Okay. Then the interval, we're going to do x bar sub 1 minus x bar sub 2. So I'm going to just do the largest minus the smallest. So I'm going to do 43 minus 40. Plus or minus. Now, you've got to find the degrees of freedom, so we'll wait to do that. I'm just going to write t with so many degrees of freedom, and then the square root of s squared over n plus s sub 2 squared over n. Okay? So if I put that in the calculator, and I go to stat, and I go to test, I go to toSamp t int, there it is right there, number 0, and I put in my deal stats. So I'm going to put in 43 and 2 and 20, 40 and 3 and 20, and let's see, confidence level 95%. Okay, we're not going to pool, and we're going to calculate. So our degrees of freedom here are 33.1. So I'm just going to put in a t with 33.1 degrees of freedom. I just needed the calculator to calculate that for me. And you guys could see it did it right there. Okay. Now if I want to know what that is, what that t value is, I do second distribution, inverse t. 95% confidence interval means that it starts at the 0.025 and ends at the 0.975. So 0.975 with 33.1 degrees of freedom, and that t would be 2.03. Okay, so this is actually 2.03. All right, and then we got to get the interval. So the interval goes from 1.36 to 4.64. And we are 95% confident that root B is between, we are 95% confident that the average time on root B is between 1.36 and 4.64 minutes longer. Now, if you did when you put this in the calculator, if you did your x sub bar sub 1 as 40 and your x bar sub 2 as 43, the only difference is these are going to be negative. So you would write this as we are 95% confident that the average time on root A is between 1.36 and 4.64 minutes shorter. Okay, that's all the negative means. And then the answer to the second question, the guy says you'll save that you will save 5 minutes if you go root A. Well, 5 minutes is not in our interval. So, as a matter of fact, the entire interval is below 5 minutes, so there's absolutely no evidence that you'll save 5 minutes. So that's a fairly conclusive statement.